Welcome to part 2 of double integrals and volume over a general region. Remember, a general region means our region will not be rectangular. Let's start with a quick review of how we're going to set these integrals up. If the region is bounded above and below by a function of x, we're going to integrate with respect to y first using g of x and h of x as our limits of integration in terms of y. And if the region is bounded to the left and right by a function of y, we'll integrate with respect to x first, with the limits of integration being g of y and h of y. So let's go and take a look at our first example. We want to determine the volume of the given function in the region bounded by x greater than or equal to 0, y equals x minus 1, and y equals 1/2 x. If we look at the graph down here, this segment here would come from x equals 0. This segment here would be on the line y equals x minus 1, and this segment here would be on the line y equals 1/2 x. So we can see the bounded region is this triangular region, which represents our region of integration. So looking at this region here, we need to decide whether we're going to integrate with respect to y first or with respect to x first. This region is bounded above and below by these two functions in terms of x. If we take a look from the left to the right, it actually changes. From the left to right, it's bounded by these two lines, and then once we drop below the x-axis, it's bounded by this line and x equals 0. So since this entire region is bounded vertically by two functions in terms of x, we'll integrate with respect to y first, and then with respect to x. So let's go ahead and set this up. Our function is y squared. Because it's bounded above and below by two functions, we'll integrate with respect to y first, and then with respect to x. So limits of integration with respect to y are going to be x minus 1 to 1/2 x. Remember, if we integrate with respect to y, these limits of integration must be in terms of x. And then for x, the limits of integration will be from 0 all the way out to this point of intersection here. This point is 2, 1. So x will be from 0 to 2. And now we'll integrate with respect to y. That's just going to give us y to the third over 3. Now we'll replace y with 1/2 x. We'll have 1/3 times 1/2 x cubed minus, we'll have x minus 1 to the third divided by 3. This will be 1/3 times 1/8 x to the third. So this will be 1/24 x cubed. We'll leave this as minus 1/3 times the quantity x minus 1 to the third. We'll integrate all of this with respect to x on the next slide. So here we're going to have 1/24 times x to the fourth over 4 minus 1/3. Here we're going to have x minus 1 to the fourth all over 4. When you evaluate this at 2 and 0. Let's go ahead and clean this up one more time, and then we'll perform the substitution. This will give us 1 over 96 x to the fourth minus, this will be 1/12 times the quantity x minus 1 to the fourth. So we'll have 1 over 96, 2 to the fourth, minus 1/12. When x is 2, we're going to have 1 to the fourth here, minus, and then when x is 0, this will be 0. But this will be 1/12 times negative 1 to the fourth. So this ends up being 1/6. This will be minus 1/12. Over here, we're going to have minus a negative 1/12. That'll be plus 1/12. So finally, we have 1/6. So the volume over that triangular region would be 1/6 of a cubic unit. Let's take a look at a graph. In purple, we see the surface, and in red, we have the triangular region in the xy plane. So that 1/24 represents the volume under the surface above the xy plane in this red region. Let's go and take a look at another example. Here we have our function, and the region is bounded by y equals x cubed and y equals the square root of x. So the more we know about these functions, the easier it should be. Taking a look at this graph here below, this would be the graph of y equals x cubed, and this piece here would be the graph of y equals the square root of x. Notice the point of intersection would be the point 1, 1. When x is equal to 1, y is equal to 1 for both of these equations. So the region of integration is this region here. And to set this double integral up, we need to decide whether we want to integrate with respect to y first or with respect to x first. Notice that it's bounded by the two functions above and below, as well as to the left and to the right. But because these functions are already solved for y, we're going to integrate with respect to y first, and then with respect to x. So our function is 3xy minus x cubed, and we'll have dy dx. So limits of integration are going to be from x cubed to the square root of x. And then for y, it'll be from 0 to 1. If we want to integrate with respect to x first, we would have to solve both of these equations for x so that we could express the limits of integration for x in terms of y. So it's a little bit less work to set it up in this order. So we're going to integrate this with respect to y, treating x as a constant. So here we'll have 3xy squared all over 2 minus x cubed y. The limits of integration are x cubed, and I'm going to go ahead and write this as x to the 1/2 power. Let's see what we get here. Because we integrate with respect to y, we're replacing y with x to the 1/2 and x to the 3rd. And that's important to remember. So when y is equal to x to the 1/2, we'll have 3/2 x squared minus x to the 3rd times x to the 1/2, that's x to the 7/2, minus, now we replace y with x cubed. This will be x times x to the 6th. So we have 3/2 x to the 7th. And this will be x to the 3rd times x to the 3rd minus x to the 6th. Let's go ahead and continue this on the next slide. Let's go ahead and clear the parentheses here. Notice we don't have any like terms, so we're going to integrate this now. We'll have 3/2 times x to the 3rd over 3 minus 7/2 plus 1 would be 9/2, so we'll have 2/9 x to the 9/2 minus 3/2 x to the 8th over 8 plus x to the 7th over 7. Now we need to evaluate this at 1 and 0. But let's go ahead and clean this up before we do that. This is going to be 1/2 x cubed. One thing we can do here, it's going to be minus 3/16 x to the 8th plus 1/7 x to the 7th. Okay, so when x is equal to 1, we'll have 1/2 minus 2/9 minus 3/16 plus 1/7 minus, and then when x is 0, all of these terms will be 0. And again, to save time, I've already calculated this. It doesn't come out very nice. It's 235 all over 1008. Again, this would be the volume under the surface in the given region. Let's take a look at the graph of this. So outlined in red, we can see the region of integration. And then in purple, we have the surface. And so the volume that we found was the volume in this region here. And that's all for this video. Thank you for watching.